Welcome back, dear students, to the part 3 of this lesson, in which we are going to discuss computations formula for p-values with examples. Critical value and p-value are very important things that are supposed to be calculated, that can be continued in this lesson part also. In hypothesis testing, critical value are one of the two approaches which allow you to decide whether to retain or reject the null hypothesis when the critical region is of two-tailed or one-tailed. The other approach is to calculate the p-value. So, critical value and p-value are playing a very important role in making a decision on null hypothesis. The critical value will define the region where the test statistic is highly improbable to lie. A critical value is a cutoff value. A two cutoff values in the case of a two-tailed test that constitutes the boundary of the rejection region. Critical value divides the scale of the test statistic into the rejection region and the non-rejection region. Most of the times it is also referred as a accepting region. Coming to the examples on test statistic and p-values. Let the test is on verifying the significance of diet's effect on the gained average length of life in the mice experimentation. If the mice is equally long on either diet, then the test statistics from the t-test will closely match the test statistic from the null hypothesis, where null hypothesis propagate that there is no difference between two groups and the resulting p-value will be close to 1. It won't reach to 1 because the groups will probably not equal in real life. Most of the times theoretically may agree, but practically there is a lot of difference. If however there is an average difference in longevity between the two groups, then the test statistic will move further away from the value predicted by the null hypothesis and the p-value will get smaller. The p-value will never reach to 0 because there is always a possibility even if the pattern in the data occurred by a chance. How do you calculate the p-value? P-value are usually automatically calculated by the statistical programs, most of the times the softwares like R and SPSS, etc. Based on the test statistic and degrees of freedom, number of observations minus number of independent variables of the test, p-value will be calculated. So, degrees of freedom is important measure to compute the p-value. Dear students, what I wish to say that computation of p-value is now automation, you need not worry much on this. The calculation of p-value depends on the statistical test that is used in testing the null hypothesis. Different statistical tests have different assumptions and generate different test statistics. Picking the statistical test that best fits the data and matches the effect or relationship that is to be tested. The number of independent variables that are included in the test will matter. How large or small the test statistic needs to be to generate the exact p-value. P-value and statistical significance, the discussion part is, it is often based on by researchers to say if a particular pattern they have measured is statistically significant. Statistical significance is another way of saying that the p-value of statistical test is small enough to reject the null hypothesis to the test. The cutoff on small and non-small samples mostly followed with the measure p less than 0.05. Some fields prefer thresholds even 0.01 and 0.001 also. So, the threshold values for determining statistical significance is also known as the alpha value. Comparing the level of significance and p-values, most of the times you may be confused, they are similar, but there is a difference between level of significance and p. The term significance level alpha is used to refer to a pre-chosen probability. The term p value is used to indicate a probability that you calculate after a given study. The level of significance is used to judge whether the probability is too high to dismiss the null hypothesis or too low not to reject the null hypothesis. This not to reject is also sometimes considered as retain the null hypothesis. The probability of the null hypothesis being true is called p-value. Comparison of the levels of significance and p-value. The level of significance is denoted by the small case Greek letter alpha. It is usually assumed that alpha equal to 0.01, 0.05 and 0.01 etc. The significance levels is smaller to the acceptable probability of being wrong null hypothesis. The probability of the results under the null hypothesis, the p-value is smaller than a pre-selected significance level alpha, then the null hypothesis is rejected and the result is considered statistically significant. It is usually denoted as p less than or equal to 0.1, 0.05 and 0.001 etc. Interdependence or interpretations with computing values of p, that problem, say for example, there is a problem which is a survey related, given 27% people of India speak Hindi. As per research study, a researcher is curious whether the figure is higher in his village. Hence, he frames the null hypothesis and alternative hypothesis as follows. He tests the hypothesis. The test hypothesis that population proportion equal to 0.27, as it is 27% means 27 by 100, that is equivalent to 0.27. Alternative hypothesis says that p is more than 0.27. His interest is, his curiosity is to know whether his village literacy rate is more than 27%. Therefore, that is resembling in the alternative hypothesis as research hypothesis. Here p is the sample proportion of the people in the village who speak Hindi. So, therefore, he has conducted a survey and based on that survey he came to the conclusion. He commissions a survey in his village and find out the number of people who can speak in Hindi. He finds that 80 out of 240 people sampled can speak Hindi. What it means that the number is 80 is favorable to the Hindi speaking, number 240 is the total sample size. So, find out the appropriate p value for the researcher's test if you were assuming that the necessary conditions are met and the significance level is at 5%. Solution come to this one. Use the following data for the calculations. This is P0 stands for population proportion, n is 240. Hence, the sample size is n is 240, P0 is the population proportion. We will have find the sample proportion. Sample proportion P cap equal to 80 by 240. P cap is simplification is 0.33 and Z statistic calculation is, we know the formula Z equal to P cap minus P0 by root over P0 into 1 minus P0 by n. After making the calculations, the computational simplified value becomes Z equal to 2.09 and the p value is 2.09 and p value you have to compute with the phenomenon. We have to look at the value of 2.09 in the G table, which is obtained from the statistical tables. Of course, these are all the old methods of getting the values from statistical tables. Now, the statistical softwares are taking care. You do not worry about that, my dear students. So, we have to look into minus 2.0 in the G column and the values in 0.09 column of statistical tables. Since the normal distribution is symmetrical, the area to the right of the curve is equal to that of on the left. So, the p value will be obtained as 0.0183. Since the p value is less than the significant level 0.05, that is 5% level of significance, reject the null hypothesis. Dear students, let us summarize the overall lesson, all these parts. In part 1, we discussed about statistical decision making through critical values and hypotheses, types of tests, critical values. And in part 2, we have discussed about how to obtain the critical values, what are the factors that are influencing the critical values, what is the way we have to arrive to the p-value as well as critical values are discussed in part 2. Coming to the part 3, mostly we have dedicated this part 3 for problem solving and understanding with example on the conceptual learning, how to get p-value as well as critical value. Dear students, I hope you are clear about the concepts which are I have explained related to statistical decision making. In this lesson, we have discussed about the notions at a glance, critical value, significance level and p-value. Thank you.